Here we're looking at pie charts, how to draw them and how to read them. This is a very famous pie chart. This is the pie chart that a nurse called Florence Nightingale used when she came to Parliament to try to convince the MPs that the soldiers that she was treating in the Crimean War were actually dying much more of diseases than in the battle, as they assumed. Now, she was a nurse and she was treating these soldiers, and she was very surprised by the fact that disease and illness was a much bigger cause of death than the actual war they were fighting. And nobody back home in London knew that either. So she came to Parliament to try to convince them of this, and rather than just read out the numbers or do a very basic table of numbers, she decided to use a pie chart, which very few people had used before, and this was it. Now, it doesn't look exactly like a pie chart that you would see, but it does have a lot of similar features. You can see that my black and white printout is not actually very clear, so maybe you can't quite see that. But this part here, this kind of grainy part here, this was the deaths from disease. And you can see it's a much larger section than the deaths from battle wounds, which are the bits here. And the pie chart was a very effective way of showing that. It very clearly shows, I think you'd agree, that much more deaths occurring from disease, and it was a very powerful impact that it had on those MPs and got them to change the way they saw dealing with the army and treating with wounded soldiers. So that's where pie charts come from. We see them more today typically as straightforward circles. Now, you already know the most important thing about a pie chart, which is that because it's a circle, it has 360 degrees inside of it. That means that when you're making one, you need to share out that 360 degrees between whatever's going on the pie chart. So imagine I had a pie chart where I was going to try and put 10 people on the pie chart, and maybe I was going to show what their favourite colours were. I'd first need to work out how many degrees each person gets. And I do that by sharing out the 360 degrees between the 10 people. And we know as well that in maths, if we're sharing something out, that's division. So if I share out 360 into 10 people, we get 36 degrees each. Now then, if I say, okay, 2 people like the colour yellow, I know that I'll need a section of the pie chart that is 2 lots of 36, so it'd be 72 in this case. And if there was one person that liked the colour red, that section would just be 1 lot of 36. Let's look at that on a more complicated example, and you'll see this on the set of questions that you've got on the document. So here we're trying to put some students on a pie chart, and the pie chart is showing their favourite sport, or just the sports they play after school. I presume it's their favourite. Maybe they don't like it, but these are the sports they play after school. So here's a table. The table's fine. It shows the information quite clearly, but it's not very impactful, so we can make a pie chart to make it more impactful. First thing is to remember we have 360 degrees. So how many degrees is each person going to get? First, we're going to add up how many people there are. So 15 plus 10 plus 26 plus 9. Add up nice and carefully. You'll see that's 60 people. Can check these on the calculator, but do try them without the calculator first. So 60 people. Okay, so that means that if we're sharing, I'm just this working out over here, 360 degrees shared out between 60, so that's divide, what's that going to be? Well, for this one, I just remembered that I can do 36 divided by 6, so just take a 0 off both of those, and that's going to be 6, and that's going to be the same answer as 360 divided by 60. So that means 6 degrees per person. Let's write that in there so I can remember it, per person. But of course, it doesn't mean that every section here is going to be 6 degrees. It just means that each one person gets 6 degrees. So if there's 15 people here on the netball section, how many degrees is that going to be? Well, it's going to be 15 times 6, and that's 90. And I'd recommend writing these out before you start the pie chart. 10 times 6, that's 60. 26 times 6, that is 156. And then 9 times 6 is 54. Might take a bit longer to do that. I did that one before, actually, that's why I got it so quickly. But do try it on the calculator, as I said. Now, these are the degrees for the actual pie chart. One thing we could do to check we're right is add them up, and it should make 360. And it does. So I'm pretty confident that I've done that correctly. If I put these on here, it's going to make a full circle with no gaps. Well, as long as I measure it properly. Now, if you haven't got a protractor or compass or anything to measure or draw circles at home, that's okay. This part is important to do. But if you have got a protractor, try and do it as accurately as I'm doing now. If you haven't got one, try and estimate it, and that'll be better than nothing. So the pie chart I've got here is a circle already. You might draw a circle with a compass or draw around something, maybe draw around the protractor and then twist it around and do the other half. Make sure you know where the center is, and then draw a straight line from the center to the edge of the circle. Makes sense to draw it straight up, or maybe sometimes people draw it straight across. Doesn't really matter actually, but I'm going to draw mine, well, I've already drawn mine, going straight up. And then put the protractor on the center with this kind of target lined up right in the center. And I've got it pointing upwards so that my 0 is in line with that line that was already drawn. I'm now going to measure from 0 my first section. So my first section is 90 degrees. Going from 0, not from 180 in there, from 0 on the outside, go around 90. I'm going to put a mark there. And then I'm going to draw, let's use the bottom of the protractor, from the center to where that mark is there. And that's 90 degrees. I'm going to do two things now. I'm going to put 90 degrees there. Or I could have also done that, couldn't I? And I'm going to label this with netball, so I know what that is. All right, that's the first section. Now the next one, I'll just tick it off actually. That one is 60. Big mistake people make here is they do the same thing. They try and measure from here. And they measure 60 in the same way, and then they just like draw their section over the top of the netball, like they're all going to be piled up on top of each other. That's not how a pie works. A pie has sections going all the way around, and you can get different slices out. So we need to measure our next section starting from there. I'm actually going to turn this round so that it's facing the same way as the previous one was. Now I'll do the same thing. I'll put the center on there. Take your time with this. Line up the 0. Go around from 0 to 60. Make a nice clear mark there. Then draw from the center to the edge there. And that's my 60 degrees. So I'm going to label that with 60. And that was hockey. So there we go. Next one is rugby, 26. That was 156 degrees. Now, luckily, none of mine are more than 180. If they are more than 180, that might be an extra challenge for you. How are you going to do that with one of these protractors? Maybe in 2 steps. I'll let you have a think about that. But I'm doing 156 this time, so I'm going to turn it around there. Put that on there. Go around from 0. Looks like about there. Try and be as accurate as possible. Probably will be 1 or 2 degrees off. So quite a big section there. And that's what you'd expect, isn't it? Because 156 degrees, it's nearly 180, so it's nearly half a pie chart. Not my favourite sport, but there you go. Now, football, it's kind of already done, isn't it? Because we've got this section here. Why don't we just check, though, that it is actually 54 degrees? It should be pretty close. Might not be exact, but hopefully pretty close. So I'll do that by kind of pretending I was going to draw it. So I'll put that on there, line it up, and does the line at the top come in with 54? Well, kind of 52 on mine, but probably because I was just a couple of degrees out on one of these measurements here. But that's okay. It's good enough for us here. So I'll put in football and just say that that was 54 degrees. Okay, so that's that pie chart complete. It doesn't matter if you choose to put the section in different places. Maybe you started with football here. Maybe you went around this way instead. Doesn't make a difference because you could just turn the pie chart around to be in any order you want. You know, rugby and netball could be next to each other. Doesn't matter at all. As long as the sections are all on there and they are this size, that's what's important. Probably you would then add some colors to it to make it a more impactful diagram, as I was showing you earlier with the example from Florence Nightingale. But that's why I'm going to leave this one. have a go at the other ones to draw on the set of questions, but what we're going to look at now is an example of how to read a pie chart that someone else has already drawn. The same principle applies here, which is that we know we've got 360 degrees, and we just want to see how much each section represents of the total amount, which in this case is 270 ice creams. Now, if the pie chart was more simple, let me just give you an example of a really basic pie chart. Try and draw a circle here. No, that was looking pretty good to begin with, but there you go. That's our circle. Now imagine we have a pie chart that has 10 people, and this section here, these people like the colour red, and these people like the colour blue. Well, this is a very simple pie chart. How many people like red? You're probably saying 5, and that's correct. The reason you're saying 5, I think, is that you've noticed that this is half of the pie chart. And then you think, well, if that's half the pie chart and the pie chart has 10 people, that's going to be half of 10 people, so it's going to be 5 people. And that's the way to think about it. Think about it as fractions of the amount of people that we've got there. What if it was slightly more complicated? It's a slightly better circle, I think. Let's go for red there again, but this time blue and yellow are like this. And let's say there's still 10 people here. Well, we've still got half the pie chart as red, but what fraction are these? Well, these are a quarter. So you'd have to find a quarter of 10, and actually a quarter of 10, well, that's going to be 2.5, so only 2.5 people. Doesn't really make sense, actually. But you can see how you could find fractions of the total amount given what you can see on the pie chart. And that's a simple example with halves and quarters. And you might see halves and quarters sometimes on pie charts, but we haven't got that here. We've got a much more complicated set of fractions. What we can do, though, is we can make fractions because we know that all of these are out of 360. So let's start with the simplest one, actually, which is this vanilla. So we have 60 degrees out of 360. So I'm going to make a kind of table here. Vanilla is 60 degrees out of 360. It's kind of a complicated fraction, but we can simplify that quite a lot. Why don't we divide top and bottom by 10? That makes 6 over 36. We can divide them both now by 6. They're both in the 6 times table. That divided by 6, that divided by 6. It's 1 over 6. That's much better, isn't it? 1/6. So I'm actually going to label that on there straight away. We need to find, therefore, 1/6 of the total number of people, 270. That isn't quite so hard. To find 1/6, you divide by 6. So let's just do that here. Let's use the bus stop method, actually, for this one. So how many 6 is going to 2? None. How many 6 is going to 27? Well, 4 goes into 24, so I can put 4 there. And then 24, there's a remainder of 3, so I put 3 in front there. How many 6 into 30 go 5? 45. Okay, so 45 people by vanilla. That's pretty good. Now I'm going to maybe cheat a little bit here and go over to the chocolate and realize that, well, if vanilla is 60 degrees and that's 45 people, chocolate is 120 degrees, that's double 60. So I think we can do a little shortcut and do 45 multiplied by 2, because it's just double the size, so it'll be double the number of people, and that gives us 90. The fraction actually would be a third as well. That's double what 1/6 is, 2/6, the same as a third. So I'm just going to put 90 there. You might have done the same thing though. You might have done 120 over 360, simplify it down to 1/3, do this divided by 3, it gives you 90. Okay, what about 36? That looks pretty tricky at first, but actually I don't think it's quite as bad as it looks, because if we do the fraction of 36 over 360, we can simplify that down because both of these can be divided by 36. How many 36s? 1. How many 36s? 10. So actually it's 1/10 for the mince. Let's put 1/10 in there. Finding 1/10 of 270? Well, we don't need the bus stop method here because dividing by 10 is very simple to do. We just have to move all the numbers one step backwards. So 270 becomes 27. And we've got our answer. There's two more to do, but they're both the same. So actually there's really just one more to do, and it's 72. I've left this one till last. I think it's going to be the hardest one. So let's put in strawberry, and it's 72 degrees out of 360 still. Simplify this. Well, I think 6 goes into 72. It's 12, isn't it? 12 times 6. So put 12 there. How many 6s in 360? Well, there's 6 6s in 36. So I think there's going to be 66s in 360. 12 over 60. I think 6 goes in again, actually. So how many 6s there? 2. How many 6s there? 10. 2 over 10. 2 goes in both of those, so I think it's a fifth. Okay, so we have to divide, therefore, the 270 by 5. Let's do that. You might have spotted a little shortcut actually already relating to the mint. And if you've used that, well done. Let's do it the long way though. 5 and 270. Okay, how many 5s go into 2? None. How many 5s go into 27? 5 into 25, so that's 5 there with a remainder of 2. How many 5s go into 24? And it's 54, which is actually just double the mint, so we could have used that. So that was 1/5, and that's 24. And it will be the same for this one, won't it? Because it's 72 degrees, so 24. A good check would be to just add these numbers up here, just to make sure they do actually add up to 270. And if you do that, you will see that they do indeed add up to 270. So that I've written 24 there, 54, they'll add up to 270 in that case. Good thing to check your work. There you go. It's a good example of that. It wasn't a deliberate mistake, but now it's corrected. Okay, so that is how you would read a pie chart, making sure you understand everything is a fraction out of 360, and then go ahead and find those fractions. Have a go at the questions on there, and feel free to ask if you have any extra questions about this.